Hello students, in our previous lesson we had discussed about work. Today we will discuss something related to that work. As all of you know, in our day to day life, in order to perform certain activities or to do work, we need energy. So today we will discuss about how energy is related to work or work is related to your energy. As you know, we cannot imagine our life without energy. For example, you are watching this television right now. If there will be a electricity failure, you cannot watch this program. That means in order to watch this program also, you need electrical energy. So also, if you want to play, your body must play certain amount of energy. You want to walk, you want to sing, you want to dance. For everything, you need energy. So, energy is a broad phenomena that is associated with our life, but science deals with it with a precise manner. So, let us see how energy is related to work. As I said, energy is required to do certain kind of work. Now, let us have a look at a animation in front of you. Suppose I push the first ball, and when that first ball hits the second ball, the second ball again moves a certain distance. So, what do we observe here? When we hit the first ball or we give a gentle push to the first ball moves. That means we were doing some amount of work on the first ball, and in return that ball acquires certain amount of energy, and acquiring certain amount of energy it moves, and when it hits the second ball which is in front of it, then the first ball does some amount of work on the second ball for which the second ball moves, or in return we can say the second ball has gained certain amount of energy. So, here what you see, the first ball gained some energy, did some work on the second ball, and the second ball gained the energy from the first ball and it moved and it also does some work. So, what we can say is that when energy is possessed by an object, it will perform certain kind of work, or in return we can say when we perform a work on object, it acquires certain kind of energy. So, this is how we can say that energy and work are related to each other. Think of another situation. If you raise a hammer to certain height and hit it on a glass, what you will observe? The glass will break into pieces. So, what do we do here? We lift the hammer. When we lift the hammer, that means we are doing some kind of work. When we do some kind of work on that hammer, it gains some energy, it acquires some energy, and after acquiring some energy, it does a work on the glass. That is why the glass breaks. So, this is how we can clearly understand how energy is related to work or work is related to energy. And because of that, we say an object having a capacity to do work is said to possess energy. And the energy possessed by an object thus can be measured in terms of its capacity of doing work. And as you know, the unit of energy therefore will be same as that of your work, and the unit will be your joule. So, in our day to day life we can say when we do work, energy is transferred from one object to the other, or in order to do certain work we need energy. That is why work and energy both have the same unit. So when we define the amount of work or the amount of energy by the unit joule, then can you define 1 joule of energy? And that definition says 1 joule is the energy required to do 1 joule of work. Sometimes when we do the amount of energy is more, the work done is more, then in that case we use a larger quantity, that is your kilojoule. So kilojoule means 10 to the power 3 joule, or 1000 joule is equal to 1 kilojoule. Now dear students, in your lower classes also you have studied energy has a different forms. So what are the different form of energy that we know? One of the form of energy that we know is a mechanical energy. Mechanical energy, when I say, it comprises of two form again. One is potential energy, another one is your kinetic energy. And in this module, we will discuss about potential energy as well as kinetic energy. Some other form of energy are your heat energy that we use in our everyday life in order to cook food. Chemical energy, as you know that when chemical reaction takes place, it also produces some energy. Then electrical energy, in the beginning of this module I gave the example that how electrical energy is so much important in our day to day life. And obviously light energy. When we talk about all these form of energy, we know that somehow these all form of energy are connected to a prime source. That prime source of energy that we know is nothing but our sun. We say sun is the ultimate source of energy that supports life on earth. There are varieties of way also we can produce artificially, scientifically also nowadays we can synthesize energy like nuclear energy, like we can have from tidal energy, geothermal energy. So that's how we can say energy is very essential for our day to day life. So I hope dear students you understood what is the importance of energy and how energy is related to work and work is related to energy. So now we will discuss one such form of energy, that is your mechanical energy. When we say mechanical energy means when some work is done, that means some mechanical force is involved, in that case we say it is a mechanical energy. And one such energy which comes under your mechanical energy is your kinetic energy. So here dear students, when we try to define kinetic energy, it's an energy which is associated with an object when it is in motion. When something is in motion, we say the energy possessed by it is nothing but your kinetic energy. Suppose a football is lying on the ground and you kick it. When we kick it, that means we are doing certain kind of work on it, and because of the work we do on that ball, the ball starts rolling, that means it comes into motion. During that motion, the energy that it has acquired because of the work that we have done on that object, that energy is called as your kinetic energy. We can take various examples from your day to day life related to your kinetic energy. Suppose a wheel is rotating, a fan blades are moving, or a bicycle, when you are riding a bicycle, when the bicycle is in motion, that possesses kinetic energy. So any object which is in motion, we call that the energy possessed by it is nothing but kinetic energy. Now at this point, we will try to equate an expression for kinetic energy for an object. For that, what we will do? We will consider an object of mass m moving with a uniform velocity u, that we can say as uniform velocity, that is initial velocity. Let it now be displaced through a distance of s when a constant force F acts on it in the direction of its displacement. So, let us try to understand the situation. Let us assume that an object which we are going to observe or we are going to take into consideration, it is already moving, right, with a uniform velocity, that let us say u, and a force is acting on it, that let us assume as F, and it has displaced to a distance of s because of that force and in the direction of the displacement. So, how can we equate an expression for energy for this object which is in motion? Let us see. So, as we know that a force F is acting on that object, let the force be F. Now, from the work done, we know that as the displacement is S, we can write that W is equal to Fs. Now, let its velocity changes from an initial velocity of u to a final velocity of v, and let the acceleration be a during that transition from the initial velocity of u to a final velocity of v. And we have studied the three equations of motion, and one of those equations which relate the initial velocity, final velocity and the object moving with a uniform acceleration is nothing but v square minus u square is equal to 2as. V is the final velocity, u is the initial velocity, a is the acceleration and s is the displacement. So, if we rearrange this, then we can say s is equal to v square minus u square by 2a. Now, we know that F is equal to mass into acceleration. Now, substituting these values of s is equal to v square minus u square by 2a and F is equal to ma in the equation W is equal to Fs. If you substitute that, what we are going to get, that W is equal to F, as you know, mass into acceleration multiplied by the displacement s is nothing but v square minus u square by 2a. Now, the a in the numerator and the denominator, that will cancel out, and what we will get? We will get an equation half into m v square minus u square. So, we will get W is equal to half m into v square minus u square. Now, supposely we will consider the object has started from a stationary position. That means we can consider u is equal to 0. Now, putting the value u is equal to 0, we will get W is equal to half into mv square, because the u square term becomes 0. And as you know, the energy possessed by an object when we do work on it is nothing but is equal to the work done, or in other term we can write in place of W, we can write E is equal to, or we will denote it at Ek is equal to half m v square. So, this is an equation or expression that we get for the kinetic energy possessed by an object when we do certain kind of work on it and it sets into motion. So, dear students, I hope you understood how to derive the equation for the kinetic energy. Now, in order to understand it with much clarity, let's watch one video.
Kinetic energy. The energy with an object possesses by virtue of its motion is known as kinetic energy. Let's consider a smooth round ball. If we push the ball a little, it will be set in motion. The rolling ball, by virtue of its motion, is capable of doing work. Here it hits an object, such as a small wooden block, pushing the object a bit beyond its initial position. The energy of this moving ball is its kinetic energy. An object's kinetic energy depends on both mass and speed. Let's go back to our ball. This time, we'll place the ball on an inclined plane. If we place the ball at the top of the incline and let it go, it will quickly roll down, hitting the wooden block with greater energy than before and still pushing it forward. But note the new position of the object. This time, it has been moved farther than before. Now, let's increase the inclination of the plane and return the wooden block to its original position. Place the ball at the top of the incline, letting it roll freely downhill. The ball will hit the wooden block with even greater force, pushing it much farther. Again, note the new position of the wooden block, which was pushed much farther because of the ball's increased speed. This helps us see that the kinetic energy of an object will increase as the speed increases. Let's slightly modify our experiment. Take a larger ball and let it roll down the inclined plane. The ball will hit the wooden block with a great deal of force, pushing it much farther. From this, we can see that the kinetic energy also increases with an increase in the object's mass. If we apply an equation to what we have seen, we would say that kinetic energy is equal to half the mass multiplied by the square of the speed. This can also be written as kinetic energy is equal to half mv squared, where m is the mass of the object and v is the velocity. Kinetic energy is measured in joules. When the mass of the moving object is increased 2 times, its kinetic energy will also be doubled. When the velocity of the object is increased 2-fold, then its kinetic energy will increase 4 times.
Dear students, I think the video was quite clear about how your kinetic energy is dependent on the mass of the object and the magnitude of the velocity. So, if you look at the expression kinetic energy is equal to half mv square, we can see that the kinetic energy directly proportional to the mass of the object and it is also directly proportional to the square of the velocity. That means we can say if the mass of the object increases, then kinetic energy will increase, and also if the velocity will increase, then also the kinetic energy will increase. Let's think of a situation where we will have 2 objects of same mass, but the first object, let us assume the VA, object A has greater velocity and object B having a lesser velocity. In which case do you think the kinetic energy will be more? As mass of the both the object is equal, then definitely the object which has greater velocity will possess greater kinetic energy. Now similarly we can think of a situation where an object initially, if you consider, has a velocity va and another velocity in another situation, let us consider as v dash a, we can say object a if you think. Now situation 1, same object having a greater velocity. In situation b, if you see, with a lesser velocity, directly we can say in the first case the kinetic energy will be more and in the second case kinetic energy will be less. So this is how we can say the dependency of your kinetic energy on the mass of the object and the velocity of the object. So in order to understand it with a much more clarity, let's solve some of the numerical problem associated with your kinetic energy or the expression of kinetic energy. So here is the first question in front of you. The question is, an object of mass 15 kg is moving with a uniform velocity of 4 meter per second. Then what is the kinetic energy possessed by the object? So dear students, whenever we are trying to solve this kind of numericals, and as we have already discussed in terms of the units is joule. So here what you need to consider, that mass will be always expressed in terms of kilogram and the velocity will be always expressed in terms of meter per second. From the question we can clearly see the information or the data that are given to us. Mass of the object 15 kilogram, velocity is given as 4 meter per second. So directly we will put the formula Ke is equal to half mv square. So let us write it. Let us write Ek is equal to half mv square, as it is given in the question that m is equal to 15 kg, v is equal to your 4 meter per second. We will substitute these values in the equation and what we will get, half into mass 15 kilogram multiplied by velocity 4 meter per second square, and that will give us half into 15. If I only write the numerical values, that gives 16, and as you know the units for your energy will be joule, that will give us an energy of 120 joule. That means the object of mass 15 kg which is moving with a velocity of 4 meter per second will possess a kinetic energy of 120 joule. I hope you understood. Let's solve another numerical. Here is the question in front of you. What is the work to be done to increase the velocity of a car from 30 km per hour to 60 km per hour if the mass of the car is given is 1500 kg. So here we need to find out the work that has to be done. So in order to find out the work, we first need to calculate the energy possessed by the car when its velocity changes from 30 km per hour to 60 km per hour, and from that kinetic energy we will get the work done, because whatever amount of work is done, that much energy is possessed by the object. So from the energy we can find out the work done. So let's solve it. So look at here. So first that we need to solve is, we will write down first the information provided to us. Mass is 1500 kilogram. Then the initial velocity u is equal to 30 kilometer per hour. We will convert it into meter per second. For that what we will do, 30 multiplied by 1000 meter divided by your 3600 second, and if you solve it, you will find a velocity of 20 by 3 meter per second. Similarly, the final velocity was given to us as 60 kilometer per hour. So, if you solve it to meter per second, 60 multiplied by 1000 meter divided by 3600 second, and that will give us a value of 50 by 3 meter per second. So, let us find out the first, the initial kinetic energy, then the final kinetic energy. So, I will solve it. Again, we will write it as, supposedly, the initial energy we will write as E k initial, that will be is equal to half into m u square, half into 1500 kg multiplied by your u square is nothing but 25 by 3 meter per second whole square. Now, if you write only the numerical values, half into 1500 multiplied by 25 into 25 is nothing but 625 divided by 9, and as you know, kilogram, meter square and second square, if you go for that, we will get the value nothing but your joule, because that is the unit of your energy. Now, if you solve all this, you will find a value of 156,250 divided by 3 joule. So, this is our initial kinetic energy. Now, let us calculate the final kinetic energy. For that, we will write it as E k F, F stands for final, K stands for kinetic energy. So, that will again half into m v square, and let us substitute the values. Half into m is nothing but your 1500 kg multiplied by your final velocity was 50 by 3 meter per second whole square. Now, if you solve it, put the numerical values, 1500 multiplied by here 2500 divided by 9, here we will directly write as joule. That will give us a value of 625,000 divided by 3, that is joule. This is your final energy. Now, we got the initial energy and the final energy. Now is our task to find out the difference between that, so that we can find out the energy. So, work done will be is equal to a change in the energy, which is equal to your kinetic energy final minus your kinetic energy initial. If you substitute the values, it is 625,000 divided by 3 minus 156,250 divided by 3 joule, and if you solve it, the final energy that you will get is 156,250 joule, or we can write it as 156.25 kilojoule. So, dear students, you solve a similar type of numericals which is given in your NCERT textbook, so that you will understand this concept in a better way. Before we conclude today's lesson, let us look what we have learnt. So, for that I have two questions for you. Let us try to solve and answer it. The first question is, how much time the kinetic energy of an object of mass m shall change if the velocity is doubled? We have already discussed this. So, what will be the kinetic energy in the change? How many times the kinetic energy will change? So, as you know, the velocity gets double, v becomes 2v, and if you take the square of it, 2v means you will get 4v square. That means the kinetic energy gets 4 times. So, the answer will be the kinetic energy becomes 4 times when the velocity becomes double. Another question in front of you. The velocity of two objects A and B of masses 10 kilogram and 5 kilogram respectively are equal. Find the ratio of their kinetic energy. Here velocity of both the object is same, but mass is different. So, if you take the kinetic energy of the first object divided by the kinetic energy of the second object, the v square term will cancel out, so also the half. Then we will have the ratio of the mass ma by mb, which is nothing but 10 kg divided by 5 kg, that is nothing but the answer will be 1:2. So, we can see the ratio of the kinetic energy is 1:2. So, dear students, we will conclude our lesson today with this. Next class we will continue with potential energy of an object. Thank you.